Hi, everyone. Welcome to today's episode of A Golden Path to Spring 1. This one's a little different for me because it is the first one where I'm hosting myself. So, yeah, hi. And it's been a little while. I've been speaking at a bunch of conferences over in Europe. And so, time zones haven't been so great and it's always been aligned with, oh, hey, conference events. Oh, okay. Shoot. So yeah, I'm doing today's. I'll be doing Thursdays as well, and there's at least some other one there. But yeah, if you're new to this basically has been a several month running stream on Tuesdays and Thursdays at this time, which is 11 o'clock Pacific time, and a bunch of spring Kubernetes, etc. talks that are leading up to Spring 1 that is happening in the end of August in Las Vegas. So if you haven't already gotten a ticket to go there, you should. And I'm actually now speaking there, so maybe I'll meet some of you in person, which would be super cool. Yeah, so I am going to pull up my slides. But yeah, basically, if you have questions, ask questions over in the whichever platform you're using. There's at least 4 different places, I think. Feel free to ask questions there. I will get to them as I can, and some of them might end up being at the end. We'll just kind of see how it goes. But yeah, just go ahead and ask stuff there and whatnot. So, all right, adding my slides. Okay, cool. So the talk that I am giving today is called Cloud Native Security for the Rest of Us. I've given this at a few of the conferences so far, so if you may have seen this before. If so, thanks for coming again. I guess you're bored. If not, hopefully you learned something new. Basically, it's kind of like at a very high level, like a semi-intro-ish talk into cloud native security for folks who are not already basically security experts. And I created this with the whole idea of hey, I have a general idea of the cloud native ecosystem, Kubernetes, but I don't know much of anything about security. So I should, fix that and actually learn some security things. And so the things that I learned by doing that, I decided would be useful, hopefully, to other people, and created a talk on that as well. So basically, yeah, hi. If you don't know me, I'm Tiffany Jernigan. I am a developer advocate at VMware. If you still use the Bird network somewhere, I guess over here. Nope, this direction. My Twitter handle is over there. It's just Tiffany Faye J. And since there's a million other things now, if you just go to linktr.ee/Tiffany Faye, they'll have all my other social things and LinkedIn and everything else. So yeah, I am going to dive in. And this talk is about probably 50-ish minutes. So just as a heads up. Okay, cool. So just to start off, basically there is this the concept is that less is actually more. So basically the less that you have, the more secure that you can be. So for instance, make sure that you have less code. So if it's possible, try to use some sort of managed services and existing security solutions instead of trying to go and create your own. I mean, someone already did it. You don't need to go and create a bunch of code. You don't have to worry about hiring all these extra engineers to work on something that's already out there. So a lot of the time, off the shelf probably might have more effort and more eyes on it unless you basically hire your own whole team to work on it. So it's probably going to be better. I mean, obviously there's exceptions and people make new things that are really cool that are better than in some capacity than something else. But yeah. So also make sure to give fewer permissions. So for instance, basically just try to only give necessary permissions and try to avoid long-lived secrets. You don't want something sticking around for a couple of years or something and someone suddenly gets access to what you have, and then it's just someone else has access to maybe your cluster or something else. It's just not a good idea. Have fewer dependencies so that you can minimize the attack surface. So for instance, you could use a distro-less image instead of using Ubuntu. And please make sure that you keep up with the latest recommendations. So for instance, Kubernetes, periodically they'll update this security checklist that's in the docs. You can see that on the link that is there. So just kind of keep up to that. Things change. So this image is from the Kubernetes documentation. It basically breaks down the cloud, like the concept of like cloud native security into the 4 C's. So I can count 4. So we have cloud, we have cluster, we have container, and then we have code. And then for cloud, that could also be like your co-located thing or your data center if you don't run it in cloud specifically. And as a practitioner, you basically have to worry about hardening your infrastructure at every single one of these levels. Like you can't just think about, like different people might be able to think about different things, but as a whole, like as a company or whatever else it might be, you can't just like worry about one and forget about all of the rest. So first I'm going to go and talk about cluster components. So kind of reiterating, basically like if you like, if there's something that exists, try to not do it. And also, like, if you really don't need to run everything yourself, just don't, like, unless you just really have to. So instead, you should use some sort of managed Kubernetes offering. Managed services, they take care of a lot of the work for you so that you don't have to worry about it. And security and like hardening are like some of the primary value add-ons for cloud platforms that are out there. So next up, like basically like I'm going to be talking this a little bit like on the side of like control plane and like the nodes. So like make sure that you harden the control plane, like basically only allow people to interact with the API server via like the Kubernetes APIs. And the less that you have like running on your control plane servers, basically there are fewer like potential avenues an attacker can exploit to gain access to your cluster. And then a next thing is like, for instance, with TLS. So like, please use real TLS certs, such as like from Let's Encrypt, and please don't be lazy and just go and skip TLS like cert verification, like that little flag that you can add. Basically, insecure skip TLS verify is basically as good as just not having TLS at all. There is also this talk by Tabby Sable, which is PKI the wrong way. And in this talk, it's basically demonstrated how the end user ability to create client certificates for MTLS can be leveraged to gain complete control of an entire cluster. etcd, like by default, basically assumes that anyone who can successfully authenticate with MTLS has proper access. And to basically avoid this, you need to restrict access to etcd. All right, so to continue on, so make sure to use pod security standards. So like before there was pod security policies, that was the default that got deprecated in 1.21 in favor of PSS. And it's kind of complicated sometimes because there's like PSS, PSA, PSP, there's a lot of acronyms to kind of keep track of. But basically use these to prevent others from having access that they shouldn't have, such as like root access to your nodes. And then if you're using some sort of like cloud provider, for instance, there is the cloud metadata server. And it's where like credentials and information are basically given into the virtual machine. You basically almost never want pods to have access to it. There can be a bunch of like scary different types of vulnerabilities that allow attackers to access the metadata server. So for instance, someone could basically get credentials associated with the VM service account, which is not good. So like basically if a pod can access it, it can obtain your node credentials. And that typically has like extra permissions, for instance, to, I don't know, like where they could register itself into the cluster during bootstrap. So a pod with like some amount of effort and work could go and pretend, hey, I'm a node, and then get workloads assigned to it, which is super bad. All right, so now on the side of like dealing with upgrades, please make sure you update Kubernetes. Like you really need to update Kubernetes. Kubernetes has been designed so upgrades can be like relatively seamless. We've gone a pretty far away since OpenStack, where you had to go and be like, hey, let me create a new cluster. Let me move all my stuff over and then delete my old cluster. Like you don't have to do that. And just I've seen way too many people in general running old versions of Kubernetes. If you're using like some sort of managed offering, most managed Kubernetes offerings, it's just basically like a button click or two. And some of them actually even have the ability to just like enable auto upgrades. So it makes life a lot easier. And then you don't have all of these like issues that might still exist. Like basically try to stay up to date with like the newest patches, or at least as close to the newest release as possible. And the more often you update your cluster, it's a lot easier to update when there are big things that say address some sort of CV. So basically a vulnerability of some sort. And you want as few vulnerabilities as possible if you can. Basically, if there's something that's being fixed, it's probably important. So like if you're kind of scared about like what could go wrong, most likely it's probably not going to be about like things blowing up when you upgrade. It's more likely that, say, your manifest, like your YAML and such, might need upgrading, and that's basically linked to deprecation cycles. So like here's like a little example to like for like how that works. So basically, say you have like some sort of ABI version that you need to deprecate. So for instance, like Ingress, for Ingress, you have like networking.kates.io v1 beta 1. Then you end up having some sort of new API version that gets introduced. So for instance, /v1, and that was in like 119. So starting at that point, you end up getting a bunch of like huge warnings that are like, hey, Ingress, like networking Kates.io is deprecated and it'll be removed in 1.21. At this point, at least, depending on where along the cycle you are, you don't need to just drop everything and be like, okay, I need to upgrade my YAML. But you need to do it before the last minute or things are not going to go so well. So basically, like my recommendation is to plan for it. Basically, after you decommission your last 118 cluster, for instance, and like try to remember that like Kubernetes will support v1 and v1 beta during like that whole like 119 to 121, which is about a year. So in short, you basically have a whole year to upgrade your YAMLs. So not much excuse there, I guess. So if just like for your enjoyment, these are the things that need to be done for upgrading your cluster if you were to do it yourself and in the specific order. So first, you would need to update your control plane. You would need to upgrade your nodes, and then you would need to upgrade clients such as kubectl or kubectl or however you pronounce it, because it seems different everywhere. Apparently, one of the ways I say it, someone I talked to had never heard of it before, so who knows? And then also you need to adjust manifests and other resources based on the API changes that accompany the new Kubernetes version. So as you can hopefully see, you really want to use some sort of managed Kubernetes so you don't have to deal with all of this, basically. All right, so let's talk about isolating compute. So things like quotas and limits can be used so like noisy neighbors don't affect other workloads that are running on the same host. They can also prevent an attacker from using your infrastructure for like DDoS or like crypto mining. You can do things like creating taints and tolerations to be able to schedule your workloads away from like each other. You could also go and add like another layer of security by using sandbox container runtimes such as like gvisor, there's Kata, there's Firecracker, and there's other things. And basically what they do is they add another layer of compute isolation between your containerized workload and the underlying operating system kernel by adding another layer of virtualization there. So by default, on Kubernetes, every single pod can talk to every other pod. If you are not cool with that, that is where you need to have network policies. So basically, Kubernetes like assumes that you trust the underlying network. For example, that could be the network of your cloud provider. If you don't, then one way to address it is to set up a service mesh with full end-to-end encryption, for example, with MTLS. Some people might say this is overkill, but it kind of all depends. You can also go the extra mile and you can use tools like Cilium for advanced network policies, such as applying filtering on specific API routes. For example, you could be like, hey, let's allow like some pod, like client front end, some number or whatever to talk to like some user API /v1 /users. But I don't want them to be able to talk to v1 /building, and basically doing this with like the magic of eBPF. If you want to learn like a little bit more about service mesh and eBPF, you can go on YouTube and look up the Devox UK talk with myself and Matthias Hausler, and can see a little bit more about that. Yeah. So secrets. Secrets can have different RBAC permissions, and I'll go into RBAC in another section a bit later, which is role-based access control. So yeah, they can have different RBAC permissions. If you go a little bit hardcore, you could even go and encrypt them at rest. So Kubernetes basically supports encryption at rest, which will encrypt resources like secrets and etcd, which basically prevents parties that like gain access to your etcd backups from viewing the content of those secrets, which is important. Also, please do not directly put your secret data into your config maps. Use like actual secrets and have your config map go and reference them instead. Even better, don't put stuff directly in secrets. Use something that will put them in there for you. Like the whole point there is like to avoid things like committing secrets to your Git repos, which when you think about might be obvious, but it's definitely something that accidentally happens. Basically, you don't want to manage secrets yourself unless you really need to. You probably want to use some sort of like key management service, such as maybe HashiCorp Vault, their sealed secrets, Casmus, SOPs, or you could use like if you're using a cloud provider, you could use your cloud provider's KMS. And basically for using this for secret data encryption. Basically, again, of the whole concept of like using work that others have done to make your life easier and more secure instead of trying to do all the things yourself. All right, so this is where I'm going into a different section. So like people, which could be like you, maybe it's your developers, or there's robots, so maybe like automated services and code that's running on your clusters, they all need to be able to talk to the Kubernetes API so that they can do things like deploying things, scaling up and down, maybe rolling on new versions, monitoring, viewing logs, basically all of the things. But we don't want to have something like, I don't know, our autoscaler to start mining Bitcoin, or maybe some developers running away with like the user credit card database. The more realistically, it's more like someone has their laptop stolen by some like malicious actor who would then maybe try to extract the credit card database. And as a person who has had my laptop stolen, luckily no one got in, but like this is a thing. But yeah, so basically this is why I'm like choosing to dedicate like this whole next big section to user management permissions. I have a separate talk that dives into this section of things a lot more. At the end of the talk, I have a link that goes to it. But if you wanted to Google, it's just my name and then beyond cluster admin and some more text, but like that should be enough to find it. All right, so basically we have like separation between, there's two different forms of like auth. So we have authn and authz. So if someone just talks about auth, you need more context to know, like if they're just mentioning the word auth, you need more context to know what they're specifically talking about. So there's authn, which is authentication, which basically is like, who are you? Then there is authz, which is authorization, and that's what are you allowed to actually do? So first I'm going to go into authn, which is authentication. So Kubernetes is really flexible here. So you can do things like you use TLS certs. Maybe that's with your own CA, maybe not. You could use OIDC tokens with any OIDC provider, something maybe in-house like Dex or Keycloak or some SaaS like Okta. And then that can in turn plug itself in with your Cloud's IAM. So for instance, you could map your cloud provider users to your Kubernetes users. Make sure that you just like keep recalling like best practices. So like, for instance, like do things like using short-lived credentials if you can. So for example, like you could use OAuth access to tokens instead of like some sort of username and password as well. For if you're a human, which I assume most everyone watching this is, and probably not some sort of robot yet at this point, though we keep getting further and further with AI, which is cool and maybe scary depending. So humans are dealing with things like interacting via like with TLS, OIDC, service accounts, etc. And robots basically use service accounts. And like as like a little note in Kubernetes, you don't go with here, let me create a user. You give, for example, create pods permissions to like, I don't know, gene.do or whatever. And as long as someone shows up with some valid cert or IDC token for gene.do, they can go and create pods. And then there's also this Spiffy project, which you use for authenticating from one service to another. It's basically an advanced use case, but like these short-lived identities can help you move away from long-lived secrets. If it sounds something like you might be interested in, yeah, just go. There's a bunch of docs on spiffy.io. It's also part of the CNCF. All right, so now let's go into the other auth, which is authz. So basically the question here is, do you have permissions to do what you're trying to do? And so the Kubernetes API server has several different types of authorization modes. There's ABAC, which is attribute-based access control. There's Node, which is like a special purpose authorization mode that grants permissions to kubelets based on the pods they're scheduled to run. There's webhook authorization, which allows you to use a custom auth system, such as plugging into your own existing system. And the main one that most people, at least who are at least semi-familiar in this area, is RBAC, which is one that I'm going to go into next. So at a high level idea for things on Kubernetes, so basically what you do is you define some sort of role, which is a collection of permissions. So basically like what things that can be done. So for instance, I could list pods, I could maybe create deployments, I could maybe do scaling for some specific deployment, etc. And then after that, you end up binding that role to some sort of user or group or service account using a role binding or a cluster role binding. And then when you go and create all of these things, for instance, you could be like, hey, I want to have this security or this service account that has access to just view pods on the dev namespace or something like that. Once you create these things, you need to make sure that you actually audit your RBAC. So like there's a bunch of kubectl commands that you can do to be able to audit these permissions. The first one there, which is kubectl auth can I and then -- list, is there by default to be able to query the API authorization layer. The other ones you need to add, but basically with this, you can check and see, hey, did I give the permissions I think I gave? Are there too many permissions? Just like verifying that you actually did what you think. And as a note, you can't take away permissions. So like, for example, if you have a thing granting some permissions to someone to like update deployments, then you can't protect a particular one. If you need something like that, maybe like you can separate things into different namespaces, for instance. So yeah, permissions can be defined cluster-wide, or you can define them just in a specific namespace. You could also have like someone like restricting access to like a specific namespace. You could even have someone basically be an admin in their own namespace. For instance, like you can be like, hey, here is the Bob namespace, and you can do whatever you want in that, but you can't do anything in any of these other namespaces. So like this also probably is an obvious thing, but please don't give like blanket admin permissions. Like that would basically be like giving root access. And like that's not like namespaces are like can be used to just make it easier to be a little bit lazy. Like if you are kind of in doubt and someone needs just like access to a bunch of stuff, you could put that stuff into a different namespace and give them access to that namespace and just like call it a day and let them do whatever with that. All right, so the next thing here is software supply chain. So to like reference it to something that is non-tech related, that is a thing that happened in the past. So in 1982, there were the Chicago Tylenol murders. Like basically people, they couldn't figure out where along the path that something was being put into the Tylenol tablets. In the end, the solution was just like putting a seal, but like, for instance, like compare things, the transportation, for instance, is like dealing with that is avoiding a person in the middle attack. There's your factory, which could be your CI/CD pipeline. You could check that, for instance, by having the concept of some sort of secure factory. So like you could have two like brand new CI/CD pipelines, and those two pipelines could end up doing the same sort of build. You could then go and check, hey, is this binary the same as this other binary? And then there's threat modeling, so you can like identify like who the actors are in the org. Perhaps you have like disgruntled employees, etc. And to the person who asked about Keycloak, I am not going into Keycloak in this stream. I'm not sure about what the watch part meant, but yeah, I'm not doing that. Yeah, so basically like say you have some sort of new vulnerability that gets disclosed. Like, how do you determine, hey, am I specifically affected? And then if so, or either way, like how do I go and deploy like some sort of fix or some sort of mitigation? Like, how are you actually aware that you aren't like unwillingly running some sort of Bitcoin, like miner? That could be bad, but you need to know. Basically, you can't actually be confident in the software that you're running unless you know where it came from and how it got there. So things that you would want to do is like, you would want to restrict like the paths that code can take from your source repo over to production, and that you make sure that you trace deployed code back along each step of the supply chain. Like, this goes back to the concept of you can't just like worry about one little aspect. There's a whole like range of things that you need to worry about. Like, you're starting from just like the code that you are going and creating all the way to the point that it's running. Like, you have to worry about all those things along the way. So there's basically like a number of questions that you need to be like asking, or things that you need to be thinking about validating as you're going from writing your code to actually running it in production. So for instance, like, does the change come from someone that you trust? So one tool here that can help you is Sigstore's Git sign, and you can use that to sign commits so that you're like basically identifying who you are with. It's keyless, so you don't have to worry about GPG keys. You could also use Sigstore's cosign for signing container images. The next question then is the source code coming from your source repo? Like, are you pulling from where you actually think you're pulling from? And then, can only authorized people push to it? Like, you don't want some random people just being able to do that. So like, when you go and build your artifact, is that from a trusted source? Can the build system itself be trusted? Can you trust where it's running and what it's running on? And then once your artifact or your program is built, can you trust where that is being pushed and that only trusted people can push to it? Ideally, only your build system in your CI/CD pipeline is the one that can be doing the pushing. Also, make sure that you do like things like vulnerability scanning for your images to look for known CVEs. There's tools out there such as like there's Claire, there's Trivy. There's some container registries such as Harbor, which have this built in. You should also consider some sort of like OPA implementation for policy enforcement. So Gatekeeper is one of the options that's available for there. Sigstore also provides an admission controller to start like image signatures and attestations as well. So right before I get into like some example like threat models and like how to go and mitigate them, there's also another open source project called Intoto, which also helps you with supply chain security along different paths along the way. So if you just, it's like in-toto for you to look at as well. So like, one of the questions is like, who is your attacker? So like, for one example, like say someone makes change to some code that you depend on and that causes your stuff to break. So that could be maybe some sort of malicious or not maintainer of some package that your program depends on, and maybe they made a change or maybe they deleted it. So for example, there was someone like deleting, maybe someone is going to like delete a package in npm that is widely used, such as maybe leftpad or something. So to avoid things like this happening, you would want to have immutable dependencies. So like, are you vendoring your dependencies? Or if not, you're basically effectively giving someone else arbitrary write permissions to your stuff, which is not good. And then there was like an attack on build infrastructure. So for example, the SolarWinds attack. So basically code that was produced by the build server had malicious code that was injected into it that allowed external access. So like, they were able to inject like malicious code and sign it with SolarWinds signing key. So a way to not have to deal with this basically is to have ephemeral builds. So basically, don't have a dedicated machine that someone can hack into, have a build system that spins up on demand. Like, if it doesn't exist, it can't be hacked. So you could also have like hermetic builds. So like a build that doesn't have access to the outside world, where you can only do things with the code that's provided to it. You can't do things with network requests. Basically, it's fully air gapped. And also make sure that your builds are reproducible. So wanted to go into a few more things that don't directly fall in line with all the things that I've gone into so far. So basically as a long story short, if you spin up a cluster by going and clicking around in like your web console or something like, I don't know, EKS cuddle create cluster, or whatever way that you're doing with creating your cluster, that result is basically far from being production ready. Matthias Hustler and I have created a talk about this that we did at KubeCon in April. There is a link there. I thought I'd put a QR code, but I guess I didn't, but it's a pretty short one. It's just the number 1, HYDW, and H is capitalized. If you go to that sked link, it will have the video and also the slides. But yeah, so some other things that are pretty important. So backing up your cluster. So you can use a tool like Bolero, like it'll back up the things that are running on your cluster and your persistent volumes as well. Another big thing is observability. Metrics can basically help you determine if something is going on unexpectedly or help you try to solve it. There is also logging. Like good logging is basically indispensable for good security because we want to be able to audit who does what. We want to be able to see things like, okay, what user did this? And maybe things that are changed with like users or privilege changes, maybe creation, things like security events, interruptions to logging, etc. There's just a bunch of stuff that you would want to be able to see what happened. Also, you can't forget about your code. Like, yes, you can worry about the whole entire system and everything with that. Then, like, basically, if you don't worry about your code, you have a whole issue of whatever's running there. And I see a note here that basically Azure AKS has automated backups and previews, so you don't need to manually set up anything more. So that's pretty cool and something that I should look into. So here are a few other resources. So I guess, yeah, I uploaded the wrong slide deck. So this one doesn't have everything that I wanted to have on there. I guess I can quickly switch to my other screen to pull that up. Let's see, one moment. Okay, so let's see. Hopefully this is actually doing what I think it's doing. Nope, it's not. There we go. All right, technology is hard. Or I'm just bad at it. I don't know. Yeah, so here's a bunch of different resources. So if you haven't looked at the CNCF landscape, there's a lot there, like a lot of stuff. I could not tell you about everything there. There's probably somebody who can, but again, there's a lot. There's the Kubernetes docs, which have like a specific section for security. There's things about like administering a cluster. There's sigstore.dev. There's also in Toto, which I had mentioned. And then there's the QR code there is for the talk that I had previously mentioned that I did. So it's Beyond Cluster Admin, Getting Started with Kubernetes Users and Permissions. So that one's a little different than this talk in the sense of, one, it's only diving into that middle section of what I was doing. Additionally, it actually has demo, which there wasn't really time for based on how this talk was created and whatnot. But yeah, so you can see going through a bunch of those things. That was from Devox France in April. Then I have my speaker deck, which has all the, not all, but because I'm not so great at making sure it's always there, but it has a bunch of the different slides that I have. I should probably update the one for this one to have this updated slide there, but it has this one. It has the one for my other talk that's right above. It has stuff for getting started with Kubernetes, etc. So there's just a bunch of different things there. So let's see if I can use the internet properly. or not the internet, my computer. All right, so yeah, thanks. And then special thanks to whichever direction I'm facing. I don't even know anymore because I can't see it when I have this screen shared. To these lovely people who helped teach me a bunch of different things that I didn't know about security. So yeah, let's see if I figure out how to go back to just hanging out by myself. There we go. All right, so yeah, hosting myself and giving a talk. I'm not so great at it apparently, but I did it. Yay. Yeah, if there's any questions, feel free to ask them in the chat. Otherwise, yeah, you can find me. Nope. There we go. You can find me here on Twitter. And also if you go to, yeah, again, linktr.ee/Tiffany Fay, it has my other like LinkedIn and a bunch of other social networking things. I guess I could always just post that in chat because it's easier. Link. Okay. And I don't think it posts to LinkedIn. So sorry, LinkedIn, but elsewhere. So yeah, I guess if there isn't anything specifically showing up in here, yeah, just ask me anywhere on any of the other social media things. And yeah, so the next stream is on Thursday. I'll be hosting and not speaking. So come join me for that one. So yeah, have a good rest of your morning, day, or whatever different time zone that you are on. And so if you haven't heard of Spring Academy, you are now. If you go to spring.academy and you basically, if you're interested at all in learning things about Spring, which is a Java framework, so yay Java, there's a bunch of different courses on there that you can go through, and it's hands-on. You can basically learn a bunch of things there. It is on my to-do list since I need to continually learn more and more about Spring. And then, as I kind of mentioned before, we have Spring One. This year, it is co-located with VMware Explorer, so you get a combination of the two things, which is super cool. It'll be my first Spring One and first VMware Explorer, and I still don't know when my talk is, but I will be doing a talk on Kubernetes operators with Spring Boot 3 with Timo Salm. And yeah, so that's in Las Vegas from August 21st through 24th. It'll be pretty hot, but good thing there's air conditioning. So yeah, see you all there, hopefully.